Myself Sumant Kumar Pandey pursuing MSc on Geology. In this presentation I will talk about the emerging modern technologies in renewable energy for sustainable development, why we need renewables, meaning of sustainability in energy sector. First we have to understand the growth of energy demands is very rapid and it's crossing their limits day by day. Therefore, the enormous energy supply in near future depends on the improved technology for more energy generation from renewable sources. All energy solutions should be supported by utilization of renewable energy sources. So, what are renewable energy sources? Those energy sources which can be replenished by natural process in a short span of time is called renewable energy sources such as wind energy, hydropower energy, solar energy, geothermal energy, biomass energy and others. And its its exact opposite is known as non-renewable energy like oil, coal, nuclear, etc. The schematic pie chart shows the global energy matrix of 2013. It shows what are the percentage of renewable sources and different non-renewable energy sources that time. What is the meaning of sustainable development in this context? Sustainable development mainly covers the uses of renewable energy, energy security, energy policy, renewable energy applications and smart grid applications. Every day, world uses approximately 88.5 million barrels of oil. This massive scale pollutes the earth in many ways. Scientists estimate that we have consumed about 40% of world's oil. According to present estimate, at this rate we will run out of oil and gases in 50 years or so, and in about a century for coal. Since the question of renewables are pondering from decades due to its harmful effects and the problems such as climate change, energy insecurity and others. So why we are still able to get 30% of our needs from renewable energy? Why? For example, the earth get about 173 quadrillion power of solar energy to earth, but why we are not able to use that ample amount of solar energy? Although there are various reasons behind it, like the geographical and climatic factors and others, we will discuss it soon. What are the challenges and probable solutions of renewable energies? As we have discussed about, only 13% of global energy sector is fulfilled by renewables. Why? The main problem is availability, power quality issues, availability of renewable energy sources like the geographic location of solar energy. Various countries have different geography, resource location, technological barriers, cost, renewable cost installations, low efficiency of renewable energies and others. But why we need renewable and other energy sources? If since we have lot of issues with renewable energies like its installation, its cost and other things. But why we need? The first is climate change and global warming. Second, the energy crisis. For example, the energy crisis in Europe after Ukraine-Russia war. Clean energy source for sustainable and inclusive development. Unlike fossil fuels, some energy sources are totally renewable and do not emit greenhouse gases. These clean and sustainable alternative energy solutions, renewable energy sources include solar energy, hydropower, wind energy, geothermal energy, and biomass energy. Probable solutions of these issues associated with renewable energies are learning how to conserve energy, improving and modernizing energy infrastructure such as smart grid solutions, awareness, and energy-centric government initiative. The PNG on the top of the slide shows the energy, environment, and sustainable energy, economy, and equity, and how they can contribute to sustainability. Renewables and energy. We can better understand the problem and their solutions by understanding how we use energy. For example, we are not in India are not using that amount of natural gases as Europe uses in winter, but Europe do not use that amount of coal as it is used in Africa, as it is used in India. Means the global energy use is diverse and complex system, and the different elements require their own solutions. The microbial fuels and for biofuels, liquid fuels, greenhouse energy, green hydrogen energy, geothermal energy, solar energy, wind energy, hydropower energy. These are the few renewables and that could be alternative of non-renewable energy. In that list, using of modern technologies such as nanotechnology and biotechnology to increase efficiency of solar cells, productivity, energy productivity from biomass, and energy production from windmills are also in the list. Why we are not able to completely replace non-renewable energy? Since we are pondering of renewables and other sources from decades, the reason there are no viable alternatives or clean fuels in modern times. In addition, it is easy to generate energy from fossil fuels and more importantly to capture energy produced from fossil fuel combustion. As our grandmother easily cook food in coal based cooker, but she will find lot of difficulty in cooking food from solar cooker. So but we have to develop renewables so as more convenient source of energy in coming times. We otherwise we have threat of energy crisis, global climate change. We are highlighting recent advances and discussing opportunities of modern technology for achieving sustainable development and increasing potential of renewable energy sources. This is the main theme of the presentation. Solar energy. Earth receives 173 quadrillion watts power of solar energy from the sun. This ample source of energy could even store using solar cells. In year 2020, there was more than 115 gigawatts of solar installed across the world, which is more than all other generation technology put together. What are different solar power energy generation harvesting techniques? First is photovoltaic solar panels, that is invented by Albert Einstein. Thermal energy harvesting energy of in electromagnetic radiation, as sun is a sun rays are electromagnetic waves. Solar water heaters, vacuum tube solar water heater, molten salt water power. They're all of these their working principles and their functionings are beyond the scope of this presentation. Major issues with solar energy: the lower efficiency, infrastructure, and the climate and geography. The probable solutions to meet our energy needs from solar energy is using of nanotechnology and other emerging technologies for increasing efficiency of photovoltaic solar panels. Investment in solar energy research sector. Formulating solar energy policy, as India recently formulated solar energy policy, and this is the main, one can say it is a main thing in energy. When we talk about energy, the formulating energy policy, The diagram or the chart shows the how China is leading the globe in terms of solar energy production. All these data are in photovoltaic solar panels production in gigawatts DC. In this, one can find that China produces about 368 gigawatt DC. After that, United States, and the third one is India. Power in terms of solar energy production. Wind energy is sustainable. This means that for long as the sun is shining, about another 5 billion year or so, we will not run off wind power. Favorable sites includes the top of smooth rounded hills, open plains, coastal areas, mountain gaps, that and in where winds are intensified. Regions in higher northern and southern latitudes in the globe have the highest potential for the wind power. Wind resources are generally more favorable for electricity generation. In India, wind energy is also used traditionally for different purposes, for such as grinding cereals and spices, pumping out of water from wells for agriculture, using specific mechanism the state of Rajasthan, that the state of India, Rajasthan is using from centuries. Global Atlas of Winds by World Bank and Denmark Technical University, launched in 2017, is a major step in conserving renewable energy from wind. The mapping of wind energy's potential around the globe could be understood through the below window global window atlas info.in. The pie chart shows the wind power around the world. All the statistics are in gigawatts. Here about 35 gigawatts are energy are generated from wind power. Hydropower energy. Hydropower means uses of natural flow of water, moving water to generate electricity. Hydropower produces three-fourths of the world's renewable energy in terms of renewable energy, but in terms of total electricity, it produces about 16% of total energy production. This number could be tripled in upcoming times. Annual output of approximately 15,000 TWh. New emerging technology in hydropower energy generation. The first one is MHK technology. This MHK technology is a revolutionary technology in the modern era that can even capture the energy of tidal waves of oceans and produce hydropower energy that can fulfill our energy demands. There are four broad hydropower plants: run-off river hydro plant, hydropower, storage hydropower, pumped storage hydropower, offshore hydrogen hydropower. Here, hydropower means power from water. Hydro basically in this sense refers to water. The below data shows what is the percentage decrease or increase in energy generation from hydropower energy. The statistics have been taken from hydropower status report published in June 2022 by International Hydropower Association. It is a global data. So here one can find what is the capacity installed, how percentage of global energy market is fulfilled by hydropower energy. Geothermal energy. The basis of geothermal energy is the immense heat content of the energy Earth's interior. Since billions of years, it is constantly supplied by the decay of natural radioisotopes. Thus, the resource is vast potential for utilizing. Without utilization, the terrestrial heat flows from a capacity of 40 million megawatt thermal power is lost to the atmosphere without utilization of geothermal energy. Instead, the heat flow can be diverted toward heat sink created by utilization. That is the our modern emerging technologies that we have developed recently, that is enhanced geothermal system that can be understood through the schematic diagram. Around 6.5% of electricity generation of the world would be done with the help of geothermal energy. In the map you can see about India, 10 gigawatts energy will be produced from geothermal energy by 2030, as Geological Survey of India had identified about 340 hot springs around India. Biofuels, as its name, a high potential renewable. Biofuel, any fuel that is derived from biomass, that is plant or algae matter or animal waste. Most electricity generated from biomass produced by direct combustion. Biomass, this steam flow over a series of turbine blades causing them to rotate. The rotation of the turbines derives a generator produce electricity. The common generator method, dynamo method, to produce energy. Around 11% of world's energy come from biofuels or biomass. It is a huge amount of energy. That's why it is a high potential renewables like solar energy and wind energy and other like hydropower energy or geothermal energy. Biofuels can be solid, liquid or gas. So they have a wide range of application from cooking food to as liquid fuel, as even biofuel can be used in various other sectors from agriculture to transportation to power, space and technology and other sectors. Biofuels not helping a nation not just fulfilling their clean energy needs but also help in dealing and utilization of organic waste. That's why it is known as waste to fuel. The two schematic diagrams, the first one shows the sources of biomass, like where we find cattle from our lavatory and other organic waste generation systems, and the second schematic diagram shows how we convert the biomass into biofuel. Biofuels are classified into three types. The first one is ethanol, second one is biodiesel, and the third one is biogas. This classification is done by me for this presentation. The liquid biofuel in greatest production is ethanol, ethyl alcohol, which is made by fermenting starch or sugar. In USA, maize is converted into ethanol. In India, sugarcane is converted into ethanol. The second most common liquid biofuel is biodiesel, which is made primarily from oily plants. Oily plants are used to produce biodiesels like soybean, oil, palm, etc. Some algae species contain up to 10 to 40 up to 40% lipids by weight, which can be converted into biodiesel by microbial activity. Other biofuels, biogas formed from anaerobic decomposition of biomass. Means we have three types of biofuels: ethanol, biodiesel, and biogas generated from different sources, from algae or microorganisms, from maize or sugarcane, or even from oily plants. What are the advantages of biofuels? Because I have told earlier that biofuel is a future of renewable energy. Why? Because it can help in pollution control, additional income to farmer, waste to wealth, future and energy source, paddy straw to biogas. It is the main serious issue that prevents us from stubble burning. The recent Punjab Delhi case, alternative source of liquid fuels. India has also launched a national policy on biofuels 2018. It is the major step, as I am telling one more time, that we need an energy policies to conserve energy, to achieve sustainability by 2030, or half by 2030 and completely by 2050. So these are the four type of first generation biofuel, second generation, which are produced from different type of sources. First type of biofuels produced from edible sources, and the second biofuel are non-edible biomass, then algae biomass, and the other systems. Biotechnological alternative, MFC, means a microbial fuel cell is a device that converts chemical energy to electrical energy by the action of microorganisms. It is a biochemical electrochemical system that uses bacteria as the catalyst to oxidize organic and inorganic matter and consequently generate electrical current out of it. It has applications in various fields such as power generation system, biorecovery, wastewater treatment, etc. MFC technology is an emerging area of alternative renewable generation, and it offers additional opportunity for environmental remediation. Recent scientific studies have focused on MFC reactor design as well as reactor operation to increase its energy output. It is more The MFC technique is more than a energy resource. It is an alternative for bioremediation. It is for environmental protection. It is a biochemical process in which organic or inorganic molecules in the action of microorganisms generate electric current. Analytical chemistry alternative, as biochemistry has a major role in the vital role in energy sustainability. Similarly, analytical chemistry is also working in this regard. For example, pyrolysis, waste to fuel. Pyrolysis, decomposition brought about by high pressure. First, look at the data. Here one can find that the paper, glass and plastic, the comparison between paper, glass and plastic recycling, plastic is recycled the least. So what happens if we can convert plastic in fuels, as plastics are used day by day and the lots of dumps of plastics are formed every hour. A long-term and reliable plastic waste management scheme is required to avoid environmental pollution and to overcome the source of energy crisis simultaneously. Thus, the primary product of the plastic waste pyrolysis process is liquid oil, while gases, wastes, char, and HCl is bioproducts. This can be shown from the figure. The figure taken from Science Direct Research Journal, and the other details are given below the figure. One can find how the pyrolysis works, how we convert not only biomass but also plastics into liquid fuels and other type of fuels as bioproducts like gases, wax, char, HCl. The liquid oils produced from plastic waste pyrolysis have similar properties to conventional diesel, that is density 0.8 kg meter per cube and energy content 41.58 megajoule per kg. Means if we burn combust 1 kg of liquid fuel, we will get 41.58 megajoule of energy out of it. Biomass pyrolysis is usually conducted at or above 500 degrees Celsius, providing energy enough heat to deconstruct the strong biopolymers and other inorganic polymers. This is the basic working principle of pyrolysis. Hydrogen fuel, energy for future. Hydrogen is emerging as one of the leading options for storing energy and long reason transportation from renewables with hydrogen based fuels through hydrogen fuel cells. Hydrogen is the simplest and smallest element in the periodic table. However, the pathways to produce it are very diverse, and so are emissions of greenhouse gases like carbon dioxide and methane. Various pathways and green hydrogens, how we produce, like in this figure one can find how green hydrogens, gray hydrogens, blue hydrogens and turquoise hydrogens are produced. In that, green hydrogen is produced from solar energy source, means we electrolyze water from solar energy in a specific electrolyzer and convert it into green hydrogen. In gray hydrogen, in blue hydrogen, we use SMR technique. What is SMR technique? SMR is steam methane reforming. Steam methane reforming reacts with steam under 3 to 525 bar pressure in the presence of a catalyst to produce hydrogen. In this, the turquoise hydrogen is a very important hydrogen species. It is made by methane pyrolysis to produce hydrogen and solid carbon. In future, the turquoise hydrogen may be valued as low emission hydrogen, being powered with renewable energy and carbon being permanently stored or used. Due to its decarbonization feature, means it is a decarbonization tool, the turquoise hydrogen. Hydrogen has wide range of applications, from fuel to from heat to feedstock and from to others. The green hydrogen capsule turn United Nations initiative to bring down the cost of green hydrogen. Japan in 2021 launched it will invest 3.4 billion to accelerate research in green hydrogen. India emerging as a key base for hydrogen electrolyzer produced by the 8 gigawatt capacity by 2025. Look at the quote by World Economic Forum. The time is right to tap into hydrogen, its potential to play a key role in tackling critical energy challenges. The recent successes of renewable energy technologies and electric vehicles have shown that policy and technology innovations have the power to build global clean energy industry. This is the quote by World Economic Forum in December 2021. Recent technologies, energy and sustainability. Role of nanotechnology in energy sector, similarly role of biotechnology in energy sector and sustainability, and also the role of analytical chemistry and emerging technologies. One can see the role of analytical chemistry, how biomass is converted into biofuel, similarly how carbon is captured and converted into alkane and later it converted as fuel using analytical chemistry. Similarly, nanotechnology has the potential to convert not just pollutants, capturing the pollutants, but also increasing the efficiency of renewable energy sources. For example, efficiency of photovoltaic cells of solar cells. Similarly, biotechnologies has an important role in production of biofuels, microbial production of methanes, and in different other systems. Prospects. Sustainable development is possible by use of sustainable energy and by ensuring access to affordable, reliable, sustainable and modern energy for citizens. Latest data set suggests that world continues to advance towards sustainable energy targets, means we are advancing towards sustainable energy targets. Nevertheless, the current pace of progress is insufficient to achieve goal 7 of SDG, sustainable development goal by United Nations Development Program by 2030, because disparities in access to modern energy. The science is clear: to prevent energy insecurity in future, to avoid the worst impact of climate change, emissions need to be reduced by almost half by 2030 and reach net zero by 2050. To achieve this, end our reliance on fossil fuel. The second thing, invest on as much as can be in alternative sources, improve global energy and environmental policies, use and invest emerging modern techno trends and technology, formulate strict energy laws, policies and regulations. The flowchart prepared by me shows the complete pathway. Renewable energy like solar energy, wind energy, biomass, geothermal energy. Using of scientific technologies, we can enhance geothermal into enhanced geothermal energy, biomass into cellulosic ethanol, advanced PV cells, photovoltaic cells, and others. And using policies and regulations, we can bring practical change of renewable energy. We can even replace renewable non-renewable energy very soon. So who is driving renewable energy, renewable investment in renewable energy? Since the beginning of presentation, I have in solar energy slide, tell that I have told that China is leading the race of renewable energy. China has invested about major part of its GDP to the renewable energy. It has invested even more than United States, Europe and other countries. This data from United Nations Environmental Plan, Bloomberg New Energy Finance. Here all these data are in US billion dollars. One can see that China has invested around the drastic change from 2009 to 2019. About China invested 90.1 billion US dollar. The total renewable investment around the globe is about 301.9 billion US dollar. In 2009, it was 167.8 US billion dollar. Means countries are understanding the importance of renewable energies. Nations are eagerly willing to replace non-renewable energy sources to renewable energy sources. That's why in a decade from 167 US billion dollar converted into 301 US billion dollar investment. Statistics of energy consumption from various sources, like here one can see that the 71% of primary energy consumption of South Africa is coal. Various factors behind it. First one is political regions, the second one is energy innovation systems, the high cost of renewable energy technologies. Here's only 2% of South Africa is energy needs is generated from renewable energy sources. Similarly, in Asia Pacific regions, 58.13% of energy needs are fulfilled from coal, and only 9% of energy is fulfilled from renewables. But in India, about 17% of its energy requirements are fulfilled from renewable energy sources, in which wind energy, solar energy, biopower, small hydropower, and waste to power, that is pyrolysis, and biofuels have a significant contribution. In uh, another chart, one pie chart, it shows the total energy consumption of US published by USA Energy Administration, in which only 9% of USA's energy is come from renewable energy sources. So the main thing, uh, uh, the main thing in leading the renewable energy is formulating strict energy policies and laws. What global leaders are doing for achieving renewable energy sustainability? Barack Obama, the ex-president of USA, once said, "A nation that cannot control its energy sources cannot control its future." The Indian Prime Minister Narendra Modi had said once, "India has now graduated from megawatts to gigawatts in terms of renewable energy production." Similarly, various politicians such as Jimmy Carter, Barry Sanders, Lindsey Graham, and others have also done a significant role in renewable energy sector of the modern world. Harmony Daly, the senior economist of World Bank during 1988 to 1994, said non-renewable sources should be exploited but at the rate equal to the creation of renewable sources. Narendra Modi says even small efforts to bring about a change is the social fabric eventually reap large fruits. The peace leader Mahatma Gandhi said, "Earth provides enough to satisfy every man's need, but not every man's greed." Similarly, Jimmy Carter's statement is a milestone in achieving renewable energy sources. These are the references from which this presentation is completely based on. Thank you.